Welcome back to the class Computational Neuroscience, Neural Dynamics of Cognition. This is the final part of our discussion of decision models using competitive dynamics. And I would like to put the question of decision making into a larger context. To start with, let's do another of these psychophysical experiments. You are red, you have just a 4, and now you have two choices. You can take the safe detour, or you can take the risky shortcut, which could potentially put you back to the initial state. I want you to decide, I want you to make a commitment. So, if you take the long shortcut, please put your left hand on your left knee. If you take the shortcut that's risky, put your right hand on your right knee. Do this now. Have you decided? Are you a risky person or a safety person? Now let's do this again in this task here. Again, you're red, you have a 4, you can decide to go left or go right. Take your decision now. So when I do this with the students, they usually smile at me in this situation and say, well, but here, what's the point? The point is that it's difficult to study decision making. One way to study decision making is that you put the subject into a completely irrelevant task. The subject is lying in a scanner and he can move either left hand or the right hand. Just tickle a little bit with the fingers. And the subject is told to report when he wants to tickle with the fingers, when he feels the urge to tickle with the fingers. And he should report the timing by looking at the sequence of characters that appear at a rate of 2 per second. And for example, our subject here reported that he wanted to move his left hand at the moment when he saw the Y. Now he can ask, when did he actually move the left hand? And this is the point here. Then you can see that at the moment when he felt the urge to move the left hand, some area in motor cortex is actually activated. Now this is an area that's really very close to the control of the muscles in the hand. So this is motor control, and it happens roughly a second or so before the actual movement. But now we have the point when the subject moved, and we can ask, were there other brain areas that were involved even before the subject reported his move? And in fact, there are areas in frontal cortex that would have a tendency to show activity even 2 or 3 seconds before the subject actually moves. Now this is not a one-to-one correlation, but in slightly more than 50% of the cases, looking at activity in frontal cortex was able to predict the actual movement with left hand or right hand. So this is a modern fMRI variant of the Libet experiment. And it has been puzzling because it looks like your brain knows before you self know what you want to do. So the question then is, who decides? It seems your brain decides what you want or what you prefer. Is that a philosophical problem? I don't think it's a problem, because in the end, your brain, this is you. Where else, if not in the brain, would be stored your experiences, your memories, your values? Now, your experiences are memorized in the brain. Your values are memorized in the brain. Therefore, of course, your decisions should be reflected somehow in the brain activities. Now, normally, you're in a situation where the decision is relevant. It's your values that tell you, and your experiences that tell you whether it's better to go left or go right. But these experiments have been done in a completely irrelevant situation. Left or right, this really doesn't matter. But then, it could in fact be just noisily ticklings on some areas of the brain that biased your decision. But in a way, this doesn't matter, because the whole decision did not matter in this case. So statements like, we don't do what we want, but we want what we do, which means our brain decides for you, have been made based on these kind of experiments, but as I've just indicated, you can also give a slightly different interpretation of these results. So this relates to the problem of volition, the problem of taking actions, the problem of free will, which is indeed a philosophical problem. Modern brain science tries to contribute to this. So let me summarize. Decisions are taken in the brain. Modeling indicates that we can understand these decisions as interaction between populations, and these populations compete with each other. But this is just a model. Now, relevant decisions involve personal values and experiences. And these values and experiences, I expect, are also stored in the brain. If you want to know more, you can look at the suggested reading, and of course, there's always the chapter of the Neural Dynamics book.